All right, so let's look at those plates again. So again, this looks like kind of your Frankenstein view of the world, and you see the major plates, and actually this major plate that is on off our west coast is called the Ring of Fire. And the icons there, the little triangles you can see from the bottom there. I'm looking for my pen. The little triangles then actually found it. The little triangles are active volcanoes, so it kind of makes sense, doesn't it, that along the edges of a plate we can have things like volcanoes, earthquakes, that sort of thing. Things are happening along plate boundaries. Um, then you see where we have diverging plates have that symbol. Converging plates have this symbol. We're gonna talk about the word what transforming plates or transformation or transform plate boundary. They're moving side to side, and then this is boundary uncertain. So it's the lithosphere that is actually plates of the Earth's crust and a little bit of the mantle floating around on the liquid part of the mantle called the asthenosphere. Yeah, earthquakes, volcanoes, and other interesting things happen at the plate edges. Now I've got the word tsunami footage up here, and actually I'm going to hold that thought. I have some slides in part 2 I want to introduce. But tsunamis, I'll just tell you right now, a tsunami event happens as plates create pretty much an earthquake, but specifically that earthquake happens under a large body of water. And then the thing is it can kind of just create a little bump, a little wiggle. If this is the Earth's, here's water, okay? This is the Earth's surface, a little bump. And it's a little bump when it's down here in deep water, but as you get closer to the land, okay, that little bump is a big bump when it reaches the land, and that's a tsunami. Oh, sorry. So 3 different types of motions I think we've talked about. Divergent, moving away, convergent, coming together, and these are the plates, and then transform, mean moving side to side. So here's a cool figure from your textbook. We have over here divergent boundaries, divergent plate boundaries. You see one plate moving that way, one plate moving this way. So you can see this would be, I'll put an L for lithosphere, and down here this would be A, I'll put A for asthenosphere. And then here we have plates moving past each other, a transform boundary. There's actually 2 types of convergent boundaries, and it depends on what types of plates are bumping up against each other. So for instance, here we have a C for continental plate. We have I'll put O for ocean plate here. And remember one of the things we said about ocean crust, we said that it's more dense. Okay, and actually the crust is thinner. Since it's more dense, it's going to come down here. This actually right here, we're going to call it a subduction zone. Subduction zone. And this is an important part of the recycling of the Earth's crust. So then this crust moves up and over. And you kind of see where some of the things that can happen is we can have a little hot spot created here. So we have some ridge building. The other type of, or another possibility, where you have converging plates is this, where we have 2 continental here, here's the boundary. And so since they're both light, like they're low density, okay, neither one of them is going to be subducted, and so they're both just going to squish together, okay? Excuse me, an example I'm going to show you here in a minute is the Himalayas. So I'll just take a little closer look at each one of those. This would be a divergent boundary, or the plates are moving away. Mantle rises to fill the area, and actually this right here, Mid-Atlantic Ridge, we call this seafloor spreading if they're 2 ocean plates. Okay, but it wouldn't have to be 2 ocean plates. Convergent boundaries. Well, again, where 2 plates move together. The old crust then is destroyed. Now, whether it's subducted or goes down or not, or just squishes up, that's one of 2 things. Subduction zone, I showed you a minute ago, that was where the ocean plate is going down under the land plate, the continental plate. And as it goes down, it's going to melt, okay, and it's going to just kind of recycle its material. So plates that are converging, they can be a continental and an ocean plate. They can be both ocean plates, and they can be both continental plates. So you have some possibilities there. This is an example of an ocean plate here and a continental plate here, and it's kind of like I showed you before. You kind of see this hot spot here has an opportunity to create some mountain building here. Oh yeah, characteristic then here, I think I mentioned this before, this is the trench I mentioned earlier being created here of the ocean plate being subducted. Ocean plate is denser. Yep, oceanic trench, sorry. So here's where we have converging plates too, but an ocean-ocean convergent plate. And again, we get a deep trench that's formed. Notice here we've got, we can have a chain of volcanoes or an arc of islands. So what about two plates converging that are both land? Well, continent plate converging. There's really not a subduction zone, and so the two plates kind of pile up. And like I said before, a good example of this would be the Himalayan mountains. What about the last one? So transforming boundaries are where the plates are sliding side by side. And so in that case, we don't have any subduction. No crust is destroyed or created. But what transformation boundaries really can do quite well is to create earthquakes. So you picture two places, and this actually happens on our west coast, but you picture, I'm going to do this. There's this, and they're squished together. So these are two continental plates. One wants to go this way, and one wants to go this way. Well, if they're very tight, what's going to happen is they're going to resist that movement as long as they can. And then at one point, the friction that's holding them together and the pressure that's holding them together won't work. And so they'll just jerk all of a sudden. And that release actually is what creates earthquakes. More on that.